Okay, let's take an example here. The graph below shows the velocity of the cart of Marlo's brother Laggy. Answer the following questions. Again, this is velocity against time. So V versus T graph. So you have V in the uh, y-axis, and then you have time in the x-axis. So let's just try to make our, again, positive direction as north, and then anything in the opposite direction, which is south, would be assigned as negative value or negative sign with a negative sign. So the question is, during what time intervals, so what time intervals does Laggy have a positive velocity and negative velocity? So positive velocity and then negative velocity. So positive means, again, north, and the negative sign here indicates that anything that is to the south. Okay. So now looking at your graph, you can actually identify any velocity that is to the north. And if you can see that one, that would be greater than 0 seconds, all of this until maybe here. So not touching the 0 mark, because 0 pertains to 0 velocity. So anything there would be positive velocity. So positive velocity would be time of greater than 0 seconds, but less than 30 seconds. Okay, so within that range, if you can see, all of the values there is positive, you have positive velocity. So anything that is to the north, again, they are separated by that 0 mark. 0 velocity doesn't, again, the object is not moving. Anything below that, that means that it has a negative velocity or the direction is south. So therefore, for negative velocity, so anything that is below that, so here, this up to here, these are negative velocity. So what time intervals would that be? Well, that would be greater than 30 seconds, but less than 60 seconds. So that would be the negative velocity. Again, that's the south direction. So anything that is here, that's south. This is south direction. South direction. And that is south from this 2-time interval, if you can see. And then north direction is anything that is here. That's north. Okay. And then letter B, at what time or times is the cart stationary? So stationary means not moving, or at rest. Or one way of looking at that one in our velocity time graph, that would mean that the velocity is equal to 0. Okay. So at what particular times? So if you just try to locate, well, that would be somewhere here, 1, 2, and 3. So therefore, time is equal to 0 seconds, 30 seconds, and 60 seconds. Okay. So that would be your well, the object is not moving at those instances. So let's take letter C. So for letter C, determine the acceleration of the cart along each interval. So time interval. So you're gonna start with, let's say, 0 to 10. So from 0 to 10 seconds, I'm gonna get the slope of that. Slope is, well, I can just use uh, these two here. 0 to 10 is up to here, right? That's 0 to 10. So what would be the slope of that? That would be 60 minus 0 all over 10 minus 0. So that would give me an answer of uh, positive 6 meters per second squared. Again, my final answer should be 6 meters per second squared north. Okay, so that is from 0 to that is from 0 to 10 seconds. Next, how about from 10 to 15? So I'm gonna do that one, 10 to 15. So from 10 to 15, is it not that you're just creating a straight line? And the value of that is 60. So that means the delta V in this particular case does not change. So therefore, from 10 to 15 seconds, A is equal to 0. Again, if you can see, delta V in this case, delta V is equal to 0. If there's no change in velocity, that means that acceleration is automatically 0. Okay. And well, if you can see, I'm creating a straight line from 15 seconds up to 40 seconds. So time interval of 15 seconds to 40 seconds. So I'm just gonna get the slope. So that would be this. So starting from there to here, so that would be, I'll be getting the slope of that. So I can actually use these 2 points here. I can do that, or I can go directly to 40 also. But I can just use, anyway, that is a straight line up to 40 seconds. So that means that no matter what point or points I use along that line, the slope should be the same. So I can actually use that from 15 seconds, and this is 60 meters per second. And then from here, this is my P2. Again, I don't have to use this point here. But anyway, if I'm gonna compute for the slope along that line, it should be the same. So this is 0, right? So the slope there would be 0, because this is now my P2. Remember, this is my P2. This is my P1. So Y2 is 0 minus Y1 is 60 all over, well, 30 minus 15. So that gives me negative 60 all over 15. Okay. And that should give me an answer of negative 4 meters per second. So negative 4 meters per second squared. Again, my final answer should be written as 4 meters per second squared south. Again, if you're wondering why it's south, well, we use the negative sign for south. So the final answer should be in the south direction. And then lastly, we have from this part here. So us part would be from 40 to 60. So we have, okay, we have from 40 to 60 seconds. So again, I'll just gonna compute for the slope to get the acceleration for each time interval. So that would be, again, I can use this one as my P1. So that is 40 and negative 40. This one here is my P2, which is 60 and 0. Okay. So in this particular case, if you can see, my Y2 is 0. But in your formula, the formula of your slope, it's Y2 minus Y1, right? So minus, what is your Y1? Y1 is negative 40. So that's why you have a negative minus the negative of 40 divided by or all over 60 minus, no, 40. No, it's 40. Okay, so that would be minus the negative. So if we're going to do the operation with that, that becomes positive 40 over 20. So you have positive 2 meters per second squared. Or again, positive sign indicates north direction. So I'm going to replace that one. Always try to replace in your final answer the direction. So that would be 2 meters per second squared. That would be north. Again, the north is coming from the direction. Okay. So again, this is the direction of the acceleration. But if you can see here in this particular case, the direction of your object would be south, but the acceleration is north. So this is the same example that I've shown you earlier. You have a positive acceleration, but it's moving in the south direction. Because if you can see, that's below the 0. So below 0 is negative velocity. I mean, again, negative velocity means in the negative direction. So this should be a particular object moving south, but the acceleration is to the north. Okay. So let's take the next question. How far does the car travel between 0 and 10 seconds? Well, when it says how far, this talks about the distance or just the magnitude of displacement. So just the magnitude of your displacement. And for 0 to 10 seconds, that is just this part here. So what would be the magnitude of that? So you just disregard the sign of the value that you will get from there. And that would be 10 times 60 divided by 2. So that gives you 300 meters. Okay. So that is for 0 to 10. And then how about for the next one here? Well, that's from 10 to 15. Yeah, 10 to 15 seconds. That's a rectangle. So that just be 5 times 60. So that is 5 times 60. Again, this is just 5 times 60. That would be 300 meters. So again, how did I get that one? Well, I just get the magnitude of my displacement. Okay, so the pink one is that value. Then 15 to 30 seconds. Well, that would be this part. Okay. So again, whatever the magnitude that I will get here would be the distance covered by the object. So that is just a triangle. So that would be what? 5, 10, 15, 15 seconds. The base is 15 seconds, and then the height is, well, the height is 60 divided by 2. Okay, all over 2 divided by, or I'm just gonna divided by 2. Well, if I'm gonna compute for that, you can verify. You should get 450 meters. Okay, so that would be from 15 to 30 seconds. Okay, and then next is from 30 to 40. So 30 to 40 here. Okay, so that's another triangle. That would be 10 seconds, but the velocity is negative 40. That should give you, and then, well, it's a triangle, so therefore I need to divide it by 2. That gives me negative 200 meters, but that is the displacement. But then again, for the distance, it's just 200 meters. Again, the magnitude of my displacement is given by this. So that would be 200 meters. Okay. How far? Again, how far pertains to the distance, the magnitude of your displacement. So that would be that part, 30 to 40 seconds. Okay. And yeah, that should give me 200 meters per second. Again, this is just the magnitude. And then lastly, 40 to 60 seconds. So that means that the area, if you can see here, the area is again projected towards the x-axis. So I'm not drawing under here. So it should be towards the x-axis when you try to get the area under your graph. So that's the meaning of that. So if you can see the blue blue part there, so it's again a triangle. So to get the area, that should just be, again, the base is the time, so 10, 20, that's 30 seconds, and then the velocity is negative 40, and then since it's a triangle, I'm gonna divide it by 2. Kindly verify, you should get negative 400 meters, and then again, since you're just getting how far for each time interval, so you're just gonna take note of the 400 meters. Okay. So now for letter E, we will try to get the total displacement and the total distance. So for the total distance, just the magnitude of all of this displacement. So you have 300 meters plus 450 meters plus 2, or like you think 300 plus 300. So 300 plus 300 meters plus 450 meters plus 200 meters plus 400 meters. And if you're gonna verify that one, that should just be equivalent to 1650 meters. Well, all are given just one sig. So yeah, just following that, that should be approximately equal to 2,000 meters. Okay, so approximately 2,000 meters in one significant figures, although it would be exactly 1,650 meters. Now, to get the displacement, so for the displacement now, you're gonna take the positive value as the north, here. So you're gonna take into account the negative and the positive sign. So you have positive 300 meters plus positive 300 meters plus positive 450 meters and plus the negative of 200 meters, then plus the negative of 400 meters. So the difference here is you try to take note of the signs. Okay, positive, 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 negative, negative. So you have 3 positive displacements and 2 negative displacements. Again, the negative only indicates that this should be, again, south direction, positive north. Okay, so if you're gonna get that, the answer of which would be positive 450 meters, or, well, approximately, well, we is gonna round it off. That would be 500 meters, and then positive sign. That means that the object is still in the north direction. Okay. So again, we replace, instead of positive, we use the north. So the displacement would be 500 meters north. Okay. So we're gonna do the last one. Now, this is kind of, maybe perhaps it takes time for you to be acquainted with this one. You're given the velocity time graph, but you're gonna get the position time graph. Okay, so position time graph. So that means that based on the information that you have in the velocity time graph, okay, information above from V versus time graph. Okay, so we're gonna recreate the possible form of our position time graph. So that means that, okay, that means that my graph would look like, so this would be my position in meters, and then this would be my time. This is 0 mark, second. Okay. So I'll just do a sketch. So doesn't necessarily be very accurate, but I'll just have to at least make sure that the form of my graph would look like exactly the same as based on the information that I have. So first is the first part, from 0 to 10 seconds. So from 0 to 10, so if this is my 10 seconds, for example, 20, oops, I can just 30, okay, 40, and then 50, and then 60. Okay, so what do you think is the form of my graph in the position time if the velocity has a positive slope in the velocity time graph? So this is accelerating. So if you can see in the first one, so represented by this line here. So if I gonna place this one in my position time graph, what would be its form? Well, is it not that it should be something like this? Oops, maybe too stiff, but it's no longer a straight line, because if it's a straight line means, remember that in the position time graph, that's the graph, if I have a straight line graph, that means that the velocity is constant. But here, the velocity is changing, the magnitude is increasing. And to verify the form of my curve, or on this graph here, is it not that if we want to get the instantaneous velocity, we will try to get the tangent line. So at 1 second, for example, my slope would be something like this. And that denotes a very small magnitude of my velocity. Okay? And then 2 seconds after, if you can see, the slope as I move, the slope of my position time graph here would be something like increasing, right? It becomes steeper and steeper as it reaches 10 seconds. And exactly that is what this means here. From 0 to 10 seconds, the velocity, the magnitude is increasing, okay? And it's in the positive direction. So that means that the form of my graph would something like this. So in the position time graph, if you can see not a straight line, but something like this, that denotes that the magnitude of the velocity is increasing. And again, we use this as the north. Positive direction is north. Okay. Now, second, second section, the interval of 10 to 15. So if you can see, 10 to 15 is this one here. That denotes constant velocity of 60 meters per second. So if you're gonna interpret that one back to your distance or position versus time graph, is it not that that is just a straight line graph? Because a straight line graph in your position versus time pertains to constant velocity. So that means that I'm gonna have a straight line until 15. Okay, so maybe somewhere there, right? So 15 seconds is here. So 15 seconds, this is around 15 seconds. So again, this pertains, so a straight line means in your position time graph pertains to constant velocity, constant v, okay? Constant velocity. So a straight line graph in your position time graph gives you constant velocity. The first part, if the form is something like this, increasing velocity, increasing v, okay? The magnitude is increasing. So next part, it's from 15 to 30 seconds, or actually to 40 seconds. So in this particular case, from 15 to no, maybe 30 seconds. I'm just gonna dissect them into two. So I'm gonna do first from 15 to 30 seconds. So what is the meaning of this graph if you're gonna place this one in the position time graph? Is it not that still the object is moving in the positive direction, because this is still positive velocity here? All of these are positive velocities, but the magnitude is decreasing, right? The magnitude is decreasing. So from 15 to 30 seconds, the object is still moving in the positive direction. However, the magnitude is decreasing. So it's not constant, but decreasing, okay? It's not constant, but it is decreasing. So you're gonna expect that from 15 to 30 seconds, the graph again in your position time graph is not a straight line. But what is the form? Well, is it not that this line here pertains to increasing magnitude? But what is the reverse of that as decreasing magnitude? Well, the form of your line would something like this. Okay, just think of, again, we can get the instantaneous velocity by taking the tangent lines, right? But what is the form of our graph that has a tangent lines that is decreasing in magnitude? Well, is it not that it's something like this? Okay, so to 30, it would be something like this. Why? If we're gonna verify that one, starting, well, is it not that this, the slope of this would be greater compared to the slope of this one here, correct? So that means it pertains that the magnitude decreases, okay? But still, it's moving in the positive direction because you're still gaining, if you can see. The displacement there is still positive. So, but the form of the graph is no longer straight because I have a changing magnitude. So changing magnitude of the velocity, if I'm gonna graph that one in my position versus time graph, I should expect not a straight line, but something like this. Again, this particular curve or this particular graph from 15 to 30 denotes that the object is still moving in the positive direction. However, the magnitude is decreasing, okay? So next, from 30 to 40 seconds, okay? So if you can see here at exactly 30 seconds, it stops. So that's why, well, if you're gonna get the slope of at the highest point, that would be 0. Your tangent line there is a straight horizontal line. So, but, so this is from 30 seconds to 40 seconds. So this object now, or the object, is now moving in the negative direction because this is now negative velocity. So this is moving to the south, and the magnitude is increasing, okay? So you can expect, again, from 30 to 40 seconds, it's not something like a straight line, okay? It's not something a straight line, but a curve, not a straight line, but maybe parabolic in nature, okay? And it would be something like this. Form is something like this, from there, okay? Again, to verify that my curve is something like this and not the other way around and not something like this, I'm gonna look at the instantaneous velocity. If my curve is something like this, is it not that originally, if you can see, from 30 to 40 seconds, not originally, but in my velocity versus time graph, this particular graph tells me that the object is moving in the opposite direction, but the magnitude increases, okay? The magnitude increases from 0 to comes 40 meters per second. So that means that 31 seconds and so on and so forth, comparing. So 31 seconds, if you can see, the instantaneous velocity would be something like that, and the magnitude of that would be less compared to the magnitude of the slope of something like this, right? So the slope of this is bigger, so that means that if you can see, if you're gonna draw instantaneous or tangent lines here to get the instantaneous velocity from 30 to 40 seconds, the slope will increase, which precisely the same thing as what we have shown in the velocity time graph. Here, again, this is increasing velocity, but moving in the opposite direction. Okay. Okay. So now left from 40 to 60 seconds. So from 40 to 60 seconds, in this particular case, the object is still moving. It's moving in the negative direction. So still moving the opposite direction, opposite to north, which is south. However, the magnitude decreases because, again, this is from 40 closing to 0. So again, the magnitude decreases. So if you're gonna graph that one in your position versus time, that means that you need to create a particular curve that will have decreasing in magnitude and in the opposite direction. So opposite direction meaning going south, but the line would be something like this. Okay. So until 60 seconds. So it would be something like this. So that's from 40 to uh 40 to 60 seconds. And since I got 450 meters as my final displacement, so if I gonna somehow project this at 60 seconds, the object is, it would be at positive 450 meters. So that means that this would be, so by just the information that I have, this should be around 450 meters here. And yes, and actually the highest point would be, that would be 6336. So actually the highest point here is around, this would be 1050. 1050. Okay. So that should be my sketch. Again, if you can see in my position time graph, if I have a straight line graph, it pertains to constant velocity. However, if the acceleration, if it is accelerating, that means that you have a change in velocity. If you can see, it's no longer. So all of them, if you can see, all of them is not a straight line. That is to be expected. So if the graph is something like this or something like this, maybe I'm just going to use a different color. Well, if shift is something like this or something like this, that would be increasing velocity, or that means that the magnitude is increasing. Or no, I think I missed that one. I think the blue line here pertains to, sorry for that. The last part from 40 to 60, the magnitude actually decreases. The one that is increasing is something like this. So this is the increasing velocity. Magnitude is increasing. Uh, this one here pertains to decreasing magnitude. Yep. Decreasing V magnitude. Okay. So